Understanding death rates. In this course, you will need to understand some basic demographic terms that we will be referring to throughout the course. The two most important ones to understand are the age-specific and the age-standardized death rates. So the age-specific death rate allows us to look at the total number of deaths in a particular age group in a specific geographic area. Typically, age-specific death rates are calculated within a specified time period, usually 1 calendar year. So first, what we do is take the total deaths in a specified age group, and then we divide by the total population in that same age group. And typically that is multiplied by a value, typically using per 100,000 or sometimes per 1,000. Let's take a look at children in New Mexico, which is one of the states in the United States, in 2006. Our specified age group is children from ages 1 to 14 years, and our total population at those same ages is 381,910. And the total deaths in the specified age group is 37. So we divide 37 by 381,910, and we multiply by 100,000. And this gives a rate of 9.7 deaths per 100,000 children at these ages in New Mexico in 2006. The next topic focuses on a simple mathematical technique called age-standardized or age adjustment rates. So take the example of comparing cancer deaths between Mexico and Finland and comparing road traffic injury deaths between Mexico and Finland. So of course, Finland is an older population than Mexico, so you would expect cancer deaths to be more common there. Similarly, Mexico is a younger population and should have higher road traffic injury deaths. Now, if we wanted to compare these two populations, however, we'd need to take into account the fact that their age distribution is different. The age-standardized technique is thus typically used to compare prevalence in different populations or different geographic areas. It's useful when we compare age-specific death rates across populations. And there are two ways to do age standardization or age adjustment. The one is called indirect, and the second is direct. So the mathematical concept allows us to compare, for example, the rate of cancer adjusted for the older age population in Finland to that of Mexico. And similarly, we can adjust for the younger age population of Mexico for road traffic injuries to compare what the rates are to Finland. Now, a final note is that age standardization is used for broad age groups. It is not necessary or meaningful to make age adjustment for smaller age groups. For example, a narrow age group between ages 15 to 19 don't need to have age adjustment. You simply can use that narrow age group. So to understand these two concepts, and we'll be using them right throughout the course.